Hello and welcome back to everyone. My name is Helen Roth. I'm head of VIA, Vital Infrastructure Arena, hosting this parallel session on digitalization. In this fourth and final round, we will have a presentation by Rune Winther from Multiconsult. Even though he's just only one presenting here, I know you have gotten a really good challenge, Rune, that you will try to answer in your presentation. And the topic of this presentation is how to exploit rapid digital innovation in safety critical application areas. Please, for also you listening to the presentation, use the discussion forum, post questions for Rune in the discussion forum. I will put them forward in the end of his presentation. So go ahead, Rune, the floor is yours.
Thank you, Helen. And as you see, I've got a challenge from Norway in Norway, which is a state-limited company wholly owned by the Norwegian Ministry of Transportation, working, as you see on the map, on the right, a number of road projects in Norway. And Stean in Norway has presented him with this challenge. Innovators are constantly presenting new digital technologies to solve challenges in the toll industry. The potential benefit seems large, but how can I make sure the new solutions are safe enough? And that's the background for this presentation. Well, we try to at least address some of the issues, and of course, within 15 minutes, it's limited what I can do. And also, the question is rather big. But I'll try to go into some of the issues that I think are important, and also point you in some directions you might go in order to manage this challenge a bit better. But the implications, the title and the question implies that there is a problem here with digital systems in critical applications, but we've done this for decades, actually. We're using digital systems in aircraft, through nuclear power plants, and railway signal systems, so we do know how to make digital systems for critical tasks. That's really not the problem. The problem here is the speed at which new development takes place. We are presented with new possibilities in technologies all the time, in new application areas, new domains, and it's the speed of that change, of that transformation, that is my reason for concern. And actually, we've seen this before, because throughout history, we had several phases where we had rapid digital, and not digital, but rapid technological development. And I'm going to start by having a brief look back in history. And this is actually based on a very good paper written by Professor Nancy Leveson. I think she wrote this back in 1991. It was based on experiences she saw from the rapid use of increased use of software in the 70s and 80s. And she actually saw a lot of similarities between this and what happened 200 years before with the application of steam engines, which then was the literally hottest technology of the time. And there's things to be learned from history. And so I'll just have a brief look at what happened that time. So you probably all know about James Watt. He developed the first practically usable steam engine, which was a low-pressure steam engine. Now, after a while, his patent expires, and other people can start making steam engines as well. And they started to produce high-pressure steam engines. Of course, they're much more efficient. Of course, you want the maximum efficiency out of this. But this had a nasty side effect. In a roughly 30-year period, more than 230 steamboats exploded, killing several thousand people. That's roughly 7 steamboats each year exploding because of lack of understanding of the technology involved, and more specifically the boilers. So what happened? What's the reason behind this? And you should read the paper to get all the details, but a few points that are still relevant today. First of all, there was, of course, a great eagerness to exploit the new technological possibilities. Of course, this was a transforming technology. It was the driver of the industrial revolution. Of course, we wanted to do that. Of course, they did that. But there was also limited experience and understanding of the technology itself. So they sort of went ahead anyway, and okay, you got all you got efficiency and results you wanted. We also got a lot of bad side effects. And this situation is not too different from what we see today. The rapid development we see of new digital solutions, new digital technologies is immense. It's great. It's super. But it also means a lot of things you don't have too much experience on. It also means that although we do have experience from making critical digital systems in some domains, we don't have it in all domains. So in domains where we don't have that experience, it's not unlikely that we're going to repeat history and do some bad things. And I see this. We saw this in when the internet came. I see it in various other domains as well today, where there's a rapid development of digital technology, but a lack of understanding of its limitations and its consequences. So that's part of the problem. That's an important part of the problem. And one thing I see quite often is that it's a tendency to make the wrong assumptions, and that assumptions really don't correspond to reality. And one thing I often hear is that some propose a new system, and they say that, well, this is just a support system, and it's not. We assume that operators or the users, they will keep doing what they do. This is an addition to what they're already doing. Therefore, it's not critical. It's just making it better. Problem is that when we introduce, various types of digital support systems, for instance, and this might, for instance, be, these semi-autonomous driving capabilities in modern cars. People change their behavior. They operate the system. They start assuming that the system is safe while it was never actually developed to be safe. So what we see, and what worries me a bit, is that I think we're going to see a lot of functionality which was started out as nice to have, addition to, improving, actually becomes critical, but which was never actually developed to be critical. And then bad things can happen. You can get stopped. Your system, you might not be able to sell it or use it because you can't document it safe, or you're going to use it anyway, and things are going bad. I also need to talk a little bit about the characteristics of critical digital systems development and what we sort of value when we develop critical digital systems, because there is a mismatch between those things and what we really would like to do with all this new technology that we're seeing. So this is not by no means a complete list, just some things I want to mention, just to show you some of the conflicts between these things. One thing is determinism. For instance, if we test a piece of software, we give it an input, we get an output. If I repeat that exact same input, I will expect to get the exact same output. That's actually pretty important because it means that we can trust results of testing. However, that will in many circumstances mean that we can't use AI. And AI is really one of the things we would like to exploit in many situations today. But if you look at standards like the IEC 61508, for instance, you will say that when it comes to certain systems, it will say it's absolutely not recommended to use various types of AI in that context. We really like low complexity, and part of that is we want to have what we call high cohesion, low coupling. We really want to have well-defined entities with limited functionality, very simple interfaces to other entities. And point with low complexity is that, or rather, the problem with high complexity is that it makes it easier to make mistakes, but also much more difficult to detect and find your mistakes. And one consequence of this is that we really don't want to connect too many things together. But again, that is very much the essence of the digital transformation we're seeing. All the things we want to do is connecting things together, because that's when we get the synergy effect. That's when we can do things we couldn't do before. A third thing is that we only try to use well-proven solutions, lots of experience, so components with a track record before we set it into something critical, which means we really don't like to use the newest technology at all. And we also have to adhere to very strict development processes. And these processes, they are slow, tedious, and thorough, and very costly to perform. So comparing this, we see that the typical characteristics of how we do critical digital systems development is not a very good fit for what we want to do today and what characterizes the technological and digital development. So that's the problem. So what do we do about this? Well, what we want to do is, of course, we need to ensure adequate safety. But at the same time, we want to achieve at least some technological agility. That means some ability to exploit new possibilities as they come without spending years doing a lot of heavy and tedious processes to get there. And so what to do about this? And first, I just want to make a few points on high level sort of guidelines, or not guidelines, but some point to think about, which I think is important and which I experience people have difficulty realizing. And that is, first of all, please acknowledge digital systems might represent pretty complex safety issues. I also already mentioned that the criticality of a function might not be very obvious. It might seem just to be nice to have, then it becomes critical. Another thing is that software has some very, very unique failure mechanisms that you might not even believe. For instance, there are cases where one misplaced line of code caused 3 deaths. There's a situation where software couldn't manage to convert a decimal number to an integer, and as a result, the whole rocket exploded. A lot of those examples. And what they tell you is that you really need thorough methodical processes and methods to be able to avoid things like that, because they do happen. They have happened, and they will happen again. This also means that you need to ensure adequate competence on safety in digital systems, and this is a highly specialized competence. It will not be enough to have people who are skilled in general safety management and some people skilled in digital stuff. You need people who are skilled in safety management of digital systems, because this is a pretty specialized competence, as I said. And the third point is on design. I think a lot of the potential that we want to have from using digital technologies is not really in itself safety related or safety critical, but might work in relation to such systems. Really important thing to do then is to isolate the non-safety critical functions from the safety critical functions. This is about complexity, and we need to keep them separate. If you don't, you're going to be in a lot of trouble. Then I want to point you in a direction of a few more specific methods or approaches you can use. And the first one is actually pretty old. I was introduced to this methodology in the late 90s, actually, and it's been used in many industries with progressive success, and specifically for digital systems. And I think that this audience might also have a use of knowing about this if you don't already. And this is about using this kind of graphical notation to make explicit safety arguments. Now, this is not a tunnel or even safety example. This is about security and privacy. But the structure is the same. It starts on the top with a claim. It's a claim that the system is good enough, for instance, that it's safe enough. On the next level, there is an explicit argumentation why this is true. In this case, the argumentation is that, well, we're going to argue by saying that all the separate subsystems are safe enough, and also the interaction between the subsystems is safe enough. And then the argument is that if both the subsystems each of its own is safe and interaction is safe, well, then the system also has to be safe. Then we can work our way down into this structure by repeating the process and making this argument explicit, and in the end coming into evidence like a specific analysis or test or whatever who supports the claims directly. Working in this way gives us a number of benefits. It improves visibility, transparency, and overview. It has a very high adaptability. You design this argument according to your situation, which means that you're not so bound into more the predictive ways of doing this. It encourages and supports modularization and prioritization of safety management. It improves detection of missing evidence and logical fallacies in the safety arguments. Actually, I used this method once to identify missing documentation in the safety documentation of a railway signaling system. Doing this enabled me to find that missing piece of documentation. And also you will see when you do this that argumentation patterns occur. So there will be similar argumentation patterns which you can then reuse. And so what this means is that it improves both efficiency and effectiveness and thus agility of your safety management process. So I would highly recommend you to look into this. The second thing I'm going to mention is the software development process itself. Because as I said, the software development process is for critical decisions is pretty tedious and slow and thorough. On the other hand, in the software industry, many years been also focused on having more agile processes who don't produce unnecessary documentation. Doesn't spend too much time on things we're not occupied with producing actual software. We like to do that in safety critical situations as well, but we need some documentation. We need some more rigidity. But we're lucky. There are some people actually in Norway, Trondheim, who has been working on this, and they've started. Their starting point was a well-established software development process called Scrum, which is a so-called agile process. And they've made a version of this they called Safe Scrum. And what they've done is to apply Scrum to the principles of safety standards like the IS 15108, which makes it possible to actually use some of the and get some of the benefits of agile processes within the paradigm of a safety standard, and then get some of the agile effects. It's not going to be as agile as Scrum, but it's not going to be as tedious as other processes either. So finally, some final comments or summary. Please do not underestimate the complexity of the safety issues of digital systems. They are pretty complex, and it is a highly specialized competence, as I said. And if you develop safety critical digital systems, it will also be much more tedious, costly, and limited than for non-critical systems. That's a very good reason for keeping the critical stuff away from and isolated from the non-critical stuff. And these things I mentioned, you can achieve some more agility in your processes for using, for instance, these dynamic and explicit safety arguments, and also processes like Safe Scrum. So that was it. Thank you for your attention.
Thank you very much for a really interesting presentation, Rune. I have one question for you in the end. We have time for that one. How do you think research institutions and the tunnel industry should work with the issues you are talking about in order to realize opportunities safely?
Well, I think there is a lot of knowledge on how to do this in other industries. They should look to other industries and other domains and learn from them. That would be the first thing to do. Don't just jump on the wagon and use all this new fancy stuff without having a real control on what this means for safety. As I said, it's a specialized competence, but there are lots of industries or universities and others who knows how to do this in other domains. So relate to them, I would say.
Thank you. Now we are going to coming to an end of the parallel session of digitalization. I'd like to thank you for taking part. And I also would like to say a special thank to all the presenters sharing insight, best practice, and good examples. Now there's going to be a short break in the program. During the break, look around on the on-air platform, visit the Digital Expo room, or participate in the networking carousel starting in just a few minutes. It's starting 16 or 4:30. In the networking carousel, you will be able to talk with colleagues from all over Europe. So use the opportunity now for the next 20 minutes to talk with colleagues from other countries, learn, share examples, share best practices. I also hope to see you all again at 10 to 5 in the last plenary session. We will have a closing session then, where Eric Primat will give his closing remarks. So please join us at 16 or 10 to 5 in the plenary session room. Then thank you and have a nice afternoon, all of you.